Welcome my dear learners for this final lecture of our discussion on sequencing problems. In today's class, I am going to explain how to solve problems on 2 jobs M machines using graphical method. To solve problems on 2 jobs M machines using graphical method, we should plot job 1 along x-axis and job 2 along y-axis. And we should draw 45-degree lines to reach the final point. The horizontal lines in the graph will indicate the idle time for job 2. The vertical lines in the graph will indicate the idle time for job 1. While moving with an angle of 45 degree, we can create many paths. That will be clear once we solve our first problem. And finally, from the graph, we should find the total elapsed time. The formula for total elapsed time is processing time plus idle time. The definitions of total elapsed time, processing time and idle time are all discussed in our first lecture on sequencing. Let us enter to the topic of discussion and let us solve the first problem. The problem number 1 states that use graphical method to obtain the sequencing of jobs and machines. Find the total elapsed time and idle times of the jobs. So if you observe, we have 2 jobs, job 1 and job 2. He has given the sequence in which these job 1 should pass through the machines, machine A, machine B, machine C, machine D and machine E. And also he has given the processing time of job 1 in these machines. And we have job 2, he has given the sequence in which it has to be processed. And he has specified the processing time on these machines. Now totally we have 5 machines and we have only 2 jobs. So far we have discussed n number of jobs processed on 1 machine, 2 machine, 3 machine and m machines. But here we have only 2 jobs. To solve this problem, first I should plot job 1 along x-axis and job 2 along y-axis. Let me plot job 1 and job 2. So if I plot job 1 and job 2 in the graph sheet, along y-axis I should plot job 2. So let me mark y-axis. Along x-axis I should plot job 1. Let me mark x-axis. Now y-axis will indicate job 2 and x-axis will indicate job 1. Now lay down the job 1 in the sequence of in which it has to be processed through the machines. Now job 1 will enter machine A at 0 time and it will be processed for 3 units because he has not given in what units he has specified the time. So therefore from time 0 let me mark 3 units 1, 2 and 3. So we have 1, 2, 3, 4, 17 units of time. So now at time 0 job 1 will enter the machine A and will be processed till 3 units. So therefore from 0 to 3 job 1 will be processed in machine A. Now after 3 units of time, job 1 will be shifted to machine B and will be processed for 4 more units of time duration. So from 3 I should count 4 more units of time. So if I count 4 more units, 1, 2, 3, 4. So 3 plus 4 is 7. From 3 units of time till 7 units of time, job 1 will be processed in machine B. So I marked machine B. Next, job 1 will be shifted to machine C after 7 units of time and it will be processed for 2 units, so therefore 7 plus 2 is 9. From 7 to 9, job 1 will be processed in machine C. Next it will be shifted to machine D at 9 units and will be processed for 6 more units, so therefore 9 plus 6 is 15. So from 9 units to 15 units, job 1 will be processed in machine D. So finally job 1 will be shifted to machine E at 15 units of time and will be processed for 2 more units. So from 15 to 17, job 1 will be processed in machine E. So this completes the sequence A, B, C, D, E, and processing time 3 plus 4 7, 7 plus 2 9, 9 plus 6 15, 15 plus 2 17. So this completes the sequence and processing time of job 1. Similarly, I should mark the sequence and processing time of job 2 along y-axis. So if I mark, I'll get, we have time durations 1, 17. Let us keep it at 18 and see. Now job 2 will enter machine B at 0 units of time and will be processed for 5 units. So therefore job 2 will enter at time 0 and will be processed for 5 units of time on machine B. Now it will be shifted to machine C at 5 units and will be processed for 4 more units. So 5 plus 4 is 9. So from time duration 5 units to 9 units, it will be processed in machine C. From 9 units to 3 more units, it will be processed in machine A. So 9 plus 3 is 12. From 9 units to 12 units, it will be processed in machine A. So mark machine A from time 9 to 12. After 12 units, it will be shifted to machine D and will be processed for 2 more units. So therefore 12 plus 2 is 14. So from 12 to 14, it will be machine D, and finally 14 plus 6 is 20. So therefore 19, 20. So from 14 units to 20 units of time, it will be processed in machine E. So this completes the sequence and time duration of job 1 and job 2 on their respective machines, which I have transferred to the graph sheet. So once you have transferred this to the graph sheet, now I should identify the regions of machines. To identify the regions of machines, now this is the region of machine A and this is the region of machine A. So therefore, if I move machine A vertically upwards and machine A vertically upwards, we'll have a crossed box what we'll obtain. What I mean to say is that if I move upwards for machine A, I'll be moving like this, and from machine A towards job 2, if I move, I'll be moving horizontal. So therefore I'll be moving like this. So we'll get the zone of machine A. So if I move in this order, so the zone of machine A will be from here till here. So this is machine A and here we have machine A. So therefore we will get the rectangular box. Since the time durations are same, we will be getting the square, because machine A on job 1 will be for 3 units, machine A and job 2 is also for 3 units, therefore I am getting a square for machine A. So mark machine A. Therefore I have marked machine A. Similarly for machine B, so machine B is moving here like this and machine B is moving like this, so therefore the common region for machine B is from here till here. So I'll get the rectangle for machine B. So mark machine B. So we have marked machine B. Next, for machine C, we'll be moving like this and we'll be moving like this. So therefore machine C will be from this point till this point. So mark the region of machine C also. I'm marking the region of machine C. This is for machine C. Now coming for machine D, so we'll be moving like this for machine D, and here we have machine D. So therefore the common region for machine D will be here and till here. I'll be getting a rectangle for machine D also. This is for machine D. Finally, before moving for machine E, I should mark the finishing point. To mark the finishing point, you should know the total processing time on job 1 and total processing time of job 2. The total processing time of job 1 is 17 units. Total processing time of job 2 is 20 units. So therefore, the finishing point is 17, 20. So mark 17, 20 on this graph sheet. So this is 17 and this is 20. So 17, 20 is the finishing point for us. So this is the finishing point. Finishing point is marked by knowing the processing time of job 1 17 and processing time of job 2 20. So 17, 20 is the finishing point for us. Now finally I am marking for machine E. So machine E will be moving like this and we have machine E here. So therefore the zone for machine E, which is a rectangle for me, will be like this, which is touching the finishing point for us. It need not be always. So this is for machine E. Thereby I have completed the regions of machine A, B, C, D and finally E. Now we have marked job 1 along x-axis, job 2 along y-axis, and we have also marked the regions of machines on this graph sheet. Draw 45-degree lines to reach the finishing point. Before drawing the 45-degree lines to reach the finishing point, one important thing is that while moving along 45 degree till the finishing point, if you are obstructed by the machines, you cannot cross over. What I mean to say is that I am moving at an angle of 45 degree. If I crash on machine B, I cannot cross it over. So during that time, either you can move horizontal or you can move vertical. Here the only option is I can move vertically upwards. Now once I reach this point moving vertically upwards, again I can continue moving 45 degree. If in case we have a machine exactly at the origin, let us say machine B is here from 5 till 5, let us say for an example, then you should start from origin but you cannot pass the machine. That is the condition, right? So therefore at that, if such situations are arising, then what you can do is that starting from origin 0, you can move horizontal, reach the end point of that machine. Now you can start moving 45 degree. That will create you the path 1, and path 2 will be move vertically upwards and then start moving at 45 degrees if the machine is exactly at the origin. So move horizontal. Once the machine is passed, start moving at 45 degrees. That will give you the one path. Or move vertical, once the machine is passed, move at angle of 45 degrees. That will give you the path number 2. So like that we can solve for machines exactly coming at the origin. Here no need to worry, machine is not at the origin. So therefore starting from the origin I should always move at an angle of 45 degrees only till we reach the finishing point. So starting at an angle of 45 degree, no need to use protractor because we are solving it on the graph sheet. From the diagonal of this grid will be a line at an angle of 45 degree itself. So therefore moving along the diagonal of these grids, so I'll reach here, this point. Now I cannot pass the machine, so therefore the only option is I can go vertically upwards. Let me go vertically upwards. I went vertically upward. Now I can draw the line at an angle of 45 degree again. So I moved vertically upward. Now I can draw line at an angle of 45 degree. So drawing line at an angle of 45 degree, along the diagonal of the grids, I will reach this point. So I cannot pass machine D, so therefore the only option is I should move horizontal till the machine is passed. So I am moving horizontal. Once the machine is passed, now I can move at an angle of 45 degree. So but finishing point is here, so therefore I should stop at this point. So moving at an angle of 45 degree, I should stop at this point. I have stopped at that point, and now I can move vertically upwards to reach the destination. So I moved vertically upwards to reach the destination. So this will give us path 1. Now always try to get 2 paths and give comparison, that will be good. So therefore to get path number 2, the only option is I can take deviation at this point. If I take deviation at this point, I can move vertically upwards past machine D, then I can move at an angle of 45 degree and reach the destination. No other option is there. Always we should try to minimize horizontal and vertical lines, because horizontal lines will indicate idle time for job 2, vertical lines will indicate the idle time for job 1. We should always avoid the idle times. So the only option is I can take deviation here. You take deviation as nearer to the finishing point. No other deviations are possible to us, which will minimize the total elapsed time. So I am taking the deviation here to create one more path. Let me indicate path 2 by dotted lines to bifurcate. Moving at an angle of 45 degree, I should stop here because destination is this one, so I should move horizontal. So I created one more path. Let us name this path as path number 2. So this completes the 2 paths for the given problem. So path number 1 is along this way and path number 2 is along this way. This finishing point is identified based on the total processing time. Job 1 is 17, job 2 is 20. So therefore finishing point is 17, 20. So this completes the plotting of our graph. I have forgotten to write the scale. The scale for this graph is along x-axis we have taken 1 centimeter is equal to 1 unit of time, and also along y-axis we have taken 1 centimeter is equal to 1 unit of time. So this completes plotting of graph. Now I should do the calculation. Coming for the calculation, let me calculate the total time elapsed for path 1. So if I do for path 1, along path 1 for job 1, the formula for total elapsed time is known to us. Total elapsed time is equal to processing time plus idle time. Processing time plus idle time. For job 1, the total processing time is 17 units. So it is 17 plus, for job 1, vertical lines in the graph will indicate the idle time. So along path 1, you should count for vertical time duration. So here I have 2 units in vertical, 2 plus I have vertical line here 2, 1, 2, 3, 4, 5, 6. So total vertical lines are 2 plus 6. So 2 plus 6 is 8. So 17 plus 8 is 25 units. So 25 units is the answer for job 1. Now for job 2 also we should get the 25 units as a total elapsed time. Here processing times are different, but idle times are also different. So if you add processing time plus idle time along a path for job 1 and job 2, should give you the same answer. Let me verify for job 2. So for job 2, if I calculate total elapsed time is equal to, total processing time of job 2 is 20 units. So therefore it is 20 plus horizontal lines in the graph will indicate the idle time for job 2. So therefore along path 1 I should count the horizontal lines. So moving along path 1, we have horizontal line only here. So therefore the total horizontal line duration is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then I have taken 45 degree. So therefore here I have 5 units of horizontal line. So therefore idle time is 5. So therefore 20 plus 5 is nothing but 25 units. So therefore we have done the calculation properly. So total elapsed time along path 1 is 25 units. Now let us verify for path 2. So if I verify for path 2, for job 1, total elapsed time will be equal to processing time is 17 plus I should mark the vertical lines. So path 2 is also starting from the origin. Vertically I have 2 units, 1, 2. Then I have vertical lines here 1, 2, 3. That's it. So therefore 2 plus 3. So 2 plus 3. So total idle time is 5 units. So 17 plus 5 is 22 units. Similarly for job 2, the total elapsed time will be equal to, the processing times is 20 plus the idle time is nothing but the horizontal lines. So moving along path 2, I should count the horizontal lines. So I have horizontal line only here, that is 2 units. So therefore 20 plus 2 units is the idle time for job 2 along the path 2. So 20 plus 2 is again 22 units. So it is matching. So therefore our calculation is correct. So from comparing path 1 and path 2, path 2 is best because the total elapsed time is minimal. It is just 22 units. So therefore the answer for this problem is path 2 is the best path, and total elapsed time for this problem is 22 minutes. And coming for the processing time is already known to us. Processing time is 17 for job 1 and 20 for job 2, and the idle times are idle time of job 1 is 5 units and for job 2 it is 2 units. So finally he has asked us to find the sequence of jobs and machines. So now to find the sequence of jobs and machines, so first you mark machines, so to indicate the sequencing job 1 and job 2. Under machines we have A, B, C, D, E. So marking the machines we have A, B, C, D, E. Now we have recommended path 2 as the best path. The answer for this problem is path 2 with a total elapsed time of 22 units. So therefore, I am having path 2 here. So moving like this. Now identify the machine in which side the machine is lying, whether it is lying towards job 1 or job 2. Now this is the path for us. I am using the reference of path 2. So now for path 2, machine A is towards job 2. So machine A is towards job 2. So therefore, if the machine is towards the job, then that job will be taken preference as 2 and the opposite job will be taken as preference 1. Here machine A is towards job 2. So therefore, job 2 will be processed second for machine A and job 1 will be processed first. Now machine B is towards job 1, so therefore machine B will take job 1 second, it will take job 2 first. So machine B will take job 1 second and will take job 2 first. Coming for machine C is towards job 1, so therefore machine C will take job 2 as a second preference, it will take job 2 as first preference. So machine 2 will take job 1 as second preference, it will take job 2 as first preference. Coming for, so this is path 2. So coming for path 2, machine D is also lying towards job 1, so therefore machine D will take job 1 as second preference, it will take job 2 as first preference. So machine D will also take job 1 as second preference, it will take job 2 as first preference. And finally coming for machine E is also coming towards job 1, so therefore machine E will take job 1 as a second preference and job 2 as the first preference. So machine E will take job 1 as second preference and job 2 as first preference. So this is the sequencing. So coming for the sequencing, what he have asked, only in machine A job 1 will be processed first and job 2 will be processed second. In all other machines, job 2 will be processed first and job 1 will be processed second. So this is the solution for the given problem. The answer for this question is the total elapsed time is 22 units and the idle time for job 1 is 5 units and job 2 is 2 units. So path 2 is recommended from our analysis, and this is the sequencing for the problem. So this is how you should solve problems on 2 jobs M machines. This completes our discussion on sequencing problems, and also we are concluding our discussion on operations research. That's all from this lecture. Thank you all.